Hunsa Hamisurgawa, Namaskar Sabjanalaya. I will speak in English though. So welcome to this session. I think for those of you who've been here all day, it's really been a very long day, but I hope we can still excite you with the topic. Let me take you back to a couple of weeks back when I was in Dialek on a field visit. And there were women there who were walking, trudging up the hillside with at least 35 litres of water on their back. My colleague tried to carry it himself and he completely was unable to. But okay, that's a question of drinking water not being very close by. But even once they get to the home with that heavy load, is it actually safe to drink? And that is really the question that we'll be looking at now. I also had the opportunity to go and visit one of the two laboratories that have been set up in the area. So these are extremely simple laboratories. The one I visited is in a health post in Dulu municipality. And basically there is just a room there with some very simple equipment. But it's a radical development in terms of it gives the opportunity to test that drinking water locally. And normally you would have to have, you have to test drinking water within 2 hours of taking the sample in order to be able to test safely. Yeah? Obviously, if you're going to take the sample all the way to an urban area, then you don't have that time. So having that possibility to test the drinking water locally is really crucial. But that's enough from me. I'm going to invite our first speaker. Mr. Narayan Khanal, who is the chief of the drinking water, no, I haven't got it right. You can come and tell me what your water quality section of the Department of Water and Sewerage. So Mr. Khanal, I would like to welcome you for your talk. You have 15 minutes. I will give you a card saying when you've got 5 minutes left, because I think we really need to stick to time. Okay, thank you.
Okay. Good afternoon, everyone. Good evening, I think, but already we are. Thank you so much for inviting me in this side event as a keynote speaker. Maybe we have already tried because of full day we are in this conference. So I will go very shortly, briefly. The topics for me as given as Sustainable Development Goal targets for Nepal and overview of water quality in Nepal. So I will go very shortly on the SDG targets and then what are the interventions on water quality in our country, and then after the major challenges and water quality issues that will be, I will try to highlight. Before going to main text, I want to go on the status on the water quality. If you look on this slide, the medium and high level of coverage on water quality is seem about 18%, as the target at the end of 2017 was 17%. That's why it's still 9% behind we are. So it is much challenging for us. Besides this, these are the two documents that we have to endorse and that should bound us to promote the water quality in coming days. The first of all, to fulfill the mandate of our Constitution 715, which says the institutions shall have the right to access to safe water and hygiene. This is very much important for us. That is already highlighted in our Constitution, and we already know the Sustainable Development Goal target 6.1 by 2013 achieve the universal and equitable access to safe and affordable drinking water to all. These documents bound us to promote the water quality in our country. If you go on the Sustainable Development Goal, we already know the 6.1 by 2030, achieving universal and equitable access to safe and dependable drinking water, and we have already set the 1.1, the indicator, the proportion of population using the safely managed drinking water services. Joint monitoring program had already developed the normative interpretation of Sustainable Development Goals target for drinking water, as we already know. I do not go on thoroughly on all the parts, but if you look on the to shape in the water quality part, what is the meaning of safe? From the definition of the joint monitoring program, safe water means a safe drinking water is the free from the pathogens and elevated level of toxic chemical at all times. We have to point out that this point for the with comparison the water quality. And the joint monitoring program already defined the global monitoring ladder for the drinking water service. We already know from the no service to the safely managed, from the lowest point of level to the highest level of services safely managed. The safely managed, if you go on the detail on safely managed drinking water, it is defined as the use of an improved drinking water source, which is measured, located at the premises and available when needed, and free of fecal and priority chemical contamination. So our focus will go on the free of bacterial contamination and priority chemical contamination. That is very much important, that should be addressed in our presentation also. But if you look the situation, our major water quality parameter concerns, if you look on the mountainous and Himalayan region, turbidity, E. coli, lime, and fluorides are the major parameters that are very much dominant in the mountain and Himalayan region. And if you go in the Tarai region, E. coli, arsenic, iron, manganese, and fluorides. If we look on the Kathmandu Valley, all the parameters in mountain, Himalayan, and Tarai region we found in Kathmandu Valley, and we have to yet another one parameter, that is ammonia. And that shows that the Kathmandu Valley is very much vulnerable with the context of the water quality, because turbidity, E. coli, iron, manganese, and ammonia are seen. But all these parameters are not health-based, but these parameters should be considered in any way. Other major dominant parameter I already highlighted, that the arsenic situation in our country. About 10 years ago, the blanket testing on arsenic was done. It was found that about 19,000 tube wells, that means 1.75% of total tube wells have the concentration of arsenic more than 50 ppb. And at that period, and government has initiated the certain arsenic mitigation plan. That was the short term, mid term, and long term. What was the short term? The short term was the buoys and filter distributed by different agencies in different time. And mid term, arsenic safe tube wells were installed from the arsenic safe layer and constructed with a platform. And the long term mitigation plan is the construction of deboring from arsenic safe layer and pipe water supply with private connection through the limited overhead tanks. Now the government has initiated the long-term arsenic mitigation plan as a new water supply project, that is called the Tarai Madhya water supply project, that was initiated just 2 years ago throughout the 20 Tarai districts. So the short-term and mid-term programs are right now the government is not focused. The focus of the government is on the long-term sustainable water supply system. So if you look on the Sustainable Development Goal target that is approved by the government of Nepal, the status and roadmap 2016 and 30. This is the interpolation of the data for the safely managed water supply system. If you look on these 5 parameters, the population using from safe drinking water, this is the baseline is 2015, and the interpolation from 2015 to 2030. If you look on the first one, the population using the safe drinking water, by 2030, 90% population should have the safe drinking water. That is the target of the government. household with access to piped water supply should be 90% by the 2030, and basic water supply coverage should be 99%. And the major important regarding the water quality is the equally contamination at household level and at source level should be not more than 1%. That is the definition, that is the indicators that defined in the status and roadmap 2016 to 2030 by the government of Nepal. But one thing is still missing. I think the tracking of arsenic in this roadmap is missing, because arsenic contamination in 20 districts is still the problem, and we have to address the parameter anywhere in this roadmap, because in safely managed water supply system as defined in joint monitoring program leader, there should be free from E. coli and major chemical hazards. What does it mean? The major chemical hazards, the arsenic is one of the major chemical hazards that should be addressed in the anywhere in the roadmap of the sustainable development goal. That is just remarks from my side. Now I'm going to shortly, briefly highlight what are the activities that are implementing by the Department of Water Supply and Sewerage. First of all, we are implementing some water quality improvement projects. Till date, 56 projects have been completed and 72 projects are still running. And other major program, the arsenic mitigation program in 2010, this I already mentioned, and water safety plan is the major intervention for the water quality improvement program that is initiated by the government. Till date, more than 2,800 projects. In 2,800 projects, water safety plan has been initiated, but still some problem in that projects. But it's sustainability. And other measure is the water quality monitoring and water quality advocacy, distribution and point of treatment. These are the major activity that is doing, and response in emergency is a major features. And some other focus programs that is launched, that is doing by the government. These are the awareness creation program of development of training modules and ISC materials, best cases documentations, and review workshop and capacity build-up and basically and water safety plan. We are doing the varieties of training and water safety plan, starting from the engineers and local bodies, treatment plant operators, water users committees, water safety plan teams, and water users secretary. Type of audience and trainees are we are initiating. We are doing the water safety plan training, and that is very much important on the capacity development part. Okay, I am in the end of this presentation. I want to highlight some major challenges. Okay, thank you. Major challenges achieve the national and SDG target, very much challenging, because we are behind 9% still, and we have already set the target. So that's a major challenge. And other challenge is the internalize the water safety plan concept in the every project cycle, because we have more than 44,000 projects in our country. We need huge amount of investment to internalize the water safety plan. That is very much challenging part. That's why inadequate institutional capacity for water safety plan implementation. And water quality monitoring functionality and accessibility laboratory is very much challenging, because just we have 5 laboratories in the different regional levels, and we have the water kits distribution in 75 districts, and besides, even every part of the country, we have to penetrate the water quality laboratory. That is very much challenging. Besides this, we are initiating some water quality improvement program. First of all, this is the process in mainstream the water safety plan through the legislative document. All the legislative documents that are in draft part they are internalizing the water safety plan concept. And we are developing the water safety plan implementation program to the local governments from the last fiscal year. And we are adding 7 water quality mobile vans in 5 regional and labs and in 2 new provinces. And thirdly, we are updating the existing arsenic information program and water quality database and water Department of Water Supply work portal. These are the current initiation that is doing from the Department of Water Supply and Sewerage. And at last, we have to, what is the way forward? To expand and increase the government initiation on water quality. It needs the policy, budget, human resources to achieve the government and SDG target. and harmonize the existing water quality related documents with the SDG draft, ST, and draft, umbrella, WAS, FT, and AIC independent bodies. I already mentioned that all the documents on WAS are on draft condition. When it will be amended, it will be endorsed by the government. Definitely, the concept of water safety plan will be internalized in all the documents. The internalized water safety plan, that is already I mentioned, and researches and new intervention on major concern or water quality issue is the coming years. And new projects should be with private connection enriching the water quality. Till date, the government had initiated for the basic level water supply system. Now, government has initiating the all project that is implemented with the water quality improvement program that should endorse the water quality issues. And our national drinking water quality standard is going to revise and update very soon. And supporting role for the effective implementation of water quality surveillance is very much necessary, and collaboration and coordinate with the sector partner to achieve that target. Thank you. Thank you so much. These are some IEC material that is endorsed recently by the Department of Water Supply and Sewerage. This is the standard operating procedure for treatment plant. These are the documents that is related to the water safety plan implementation in the dog wells and some hand pumps. And the last one document is the water burden disease and how we dose the chlorine in the treatment plant. These are brochure and documents are distributing to the users committee and the public. Thank you. Thank you so much.
Time, that's perfect. What we thought we would do is to have the three presentations first and then just a little bit of time for discussion. So without further ado, I'd like to invite my colleague from Helvetis, Madame Bata, and then Aryan Shattenlieb from Eawag to give their presentation. Madam, I think you'll need this microphone.
Good evening, everybody. Today we are delighted to present novel pathways for this drinking water safety strategy in Midwestern region, and it's a collaboration between Helvetas Swiss Intercorporation and Eawag, Switzerland. And we are going to present the main results from the Risk Catalyst project. Actually, this Risk Catalyst project is a small component of water program of Helvetas in Nepal. I think most of you heard about this integrated water resource management program. Within that program, actually, we implemented this Risk Catalyst project, which focuses more on water quality. So here is Aryan from Eawag. We will jointly present this presentation, and welcome to all of you. So this Risk Catalyst project actually, as I mentioned earlier, is a partnership between Eawag and Helvetas, and it is funded by SDC and Risk Program for Water Security for the Poor. And the objective of this project is actually to achieve safely managed drinking water. Is Sustainable Development Goal 6.1 in remote rural communities and hill area with gravity-fed pipe water supply systems. Well, we know the rural setting of the Nepal for WAS. Actually, the rural area, they are remote area and scattered settlements, and there are small gravity systems where this operation and maintenance has been done by users committee. And there is low access to electricity as well. And the initial goal of this project is characterize the water quality at the system and household level, and identify system vulnerabilities, and systematically test interventions. So we have a experience from 2014 to till now, and the project phases were divided like initially we started in 2014, we did this desk review, Later we conducted baseline survey in 2014 and 15, which actually we triggered to start this water quality initiatives. Because in the past we were just focusing more on construction of water supply scheme, but through this baseline survey, we have a lot of learning from the implementation of the project in the past. And then we have another phase, 2015 and 16, where we further conducted studies, and we have some case studies from that phase. And after this 2017 till now, we are implementing this risk collaboration. We will present what is this risk project, what we are doing, and finally we also have the comparison of the baseline data and the data after the implementation of this risk catalyst project. So this is the summary of the baseline survey, which revealed that 2 out of 3 taps do not meet national standard for microbial water quality. The perceived water quality among the user, it was very high, that all people say the water quality is good, and only 11% say that they think that the water quality is poor. Similarly, there is no system level treatment, and there is no monitoring mechanism, and there is also low demand for this household level water treatment, and it was rarely practiced. Actually, only 19% of the household were applying this household water treatment and safe storage. And it was realized source protection should be combined with all these water supply schemes. And this is another research. Actually, we conducted this research to know about this temporal and spatial variation of the water quality, and we conducted a study for 35 days, and we measured water quality daily. And the water quality was also measured at different points, like intake, reservoir tank, tap stain at different locations. And the study revealed that water quality is not consistent. It is there is a fluctuation between the sampling point, and peak equally originate from the source. If there is higher level of this equally at the source, then it also has effect on other structures. And the study finally revealed that there is a temporal and spatial variation of the water quality. Then the guiding question for risk catalysts is, what is an effective and sustainable water safety strategy for remote alpine regions? Here, actually it's not a new thing, but we implemented this water safety plan with some more initiatives. Actually, there are some challenges of the water safety plan for implementation in the rural area, like it's difficult to monitor water quality regularly as per this drinking water quality standard of 2005 in Nepal. Similarly, there is no capacity to do all the things, and we all know about we haven't lab in the even in the district headquarters. We only have 5 regional labs, so it's really difficult to conduct microbial water quality test. So here we started our intervention from this water safety plan. There is a well-defined this process and guideline by WHO about water safety plan. But its operational part in rural area is a little bit challenging, we say. And we added other things. Here is water safety plan. We started from here, and where we did this monthly sanitary monitoring, adapted sanitary form we developed, and we trained local people. Then we added this field robust laboratories, where there are portable incubator. We will have demonstration of this incubator later. And we used these solar panels for electricity, and we trained local people. Actually, in the lab, for example, in the regional lab, actually there is a problem of this chemist. It's really difficult. But here we trained local people. They can monitor. They cannot certify, they cannot give the certificate, but they can this measure the water quality for their water supply scheme, so that the local people also have awareness about the water quality. And we also have this low-cost scheme improvement, where we implemented source protection and conservation activities in a larger area, and we added this roughing filters at intake, and in few schemes there is also this system level treatment. And one another important part, actually we lack data about water quality, and we have this centralized data management system where we use AquaFlow for the data collection. We use this mobile-based technology and tablets, and water quality result and field sanitary forms and data available online in real time. So we can see the data in Kathmandu or Switzerland immediately after this data collection. So here the important part is capacity building and behavior change campaign. All over the cycle we have this strong component where we focus on this ongoing sanitation campaign of the Nepal. So after this ODF campaign, there is a campaign for total sanitation, where we have more focus on two things. One is hand washing, another is this safe water, where we promote household water treatment and safe storage. So these are the things, and just to complement again, what is added in the water safety plan is this technology and local capacity. Similarly, the source conservation part is another, and this evidence and data management is another thing. So it's like a water safety plan plus, or we can say hybrid water safety plan. We have this here water safety plan expert, so he will also have some reflection about this. So actually in this project we implemented, in the rural area with all the component of the water safety plan. So I would like to invite Ariane to continue this presentation, and she will deliver about the research finding. What was we observed in baseline and what we observed in the end line.
Thank you very much, Madam. So I will explain a little bit more about the methodology of the REACH Catalyst project, and also, as mentioned, the results of the first year, the pilot phase. So first of all, at the beginning, we began with a scoping trip and a workshop. We wanted to assess the situation of water quality and water quality monitoring in Nepal, understand the situation, identify the gaps and the needs, and fill the gap with our project. Then we identified the sites where we would lead the intervention, and we installed 2 rural labs. And then we trained the people to perform the lab measurements in the remote laboratory, and also we trained them on the adapted water safety planning approach. In order to understand the situation before the intervention, we led a baseline survey with intense data collection, including household surveys and water quality testing at the household and scheme level. And then we began with the proper REACH implementation of the intervention. So it's here these regular monthly activities and overall system upgrades. So these activities are going to be detailed later, but they involved regular sanitary inspection of the scheme with water quality testing, all done by the local community directly on site, and system upgrades along the whole project. At the end, we led another survey to assess the impact of the approach. So what did we achieve during the year of the Catalyst project? We installed 2 rural laboratories to ensure local quality control. We established a monitoring regime for water quality sampling and system inspection. I forgot to mention it happened in the Dulu municipality. So you can see the 2 labs here and the schemes in green. So we upgraded 5 piped water schemes. We also improved the chlorination practice in an urban area, and we disseminated our knowledge. So the interventions were quite diverse. first of all, there were the system upgrades. After the sanitary inspections, we identified the risks in each system, and we implemented simple but effective measures to reduce these risks. And as Madan showed you the graph, you can see that the source is very often vulnerable, and it's the base of a lot of contamination of water in the scheme. So one of the interventions is to implement one of these simple intake filters that already prevent contamination entering the scheme. Another system upgrade is the source conservation. So here you see the plantation of plants to protect the hydrosphere. And the core of the REACH intervention was the regular sanitary inspection along with water quality monitoring by a trained staff. So, what were the results of this year? First of all, we went to 75 households to interview them about their water quality practices and perception. You can see here the intervention schemes. We implemented the intervention in 5 schemes, and we had 3 control schemes where we just led the baseline and endline and no intervention in between. The intervention schemes are the one where the REACH intervention happened. So you see in light blue the amount of households perceiving their water as safe in general. So you can see that in the intervention and control schemes it was already high at the beginning and it remained pretty high. What is interesting to see is the dark blue lines, which is the amount of people using a household water treatment system. So in the intervention scheme, 70% of the people reported using treating their water at the household level, and after our intervention, this rose up to 100% of the people using a household water treatment. And in the control area, it remained the same, so no changes. So we can see a significant improvement in uptake of household water treatment with our intervention. Then we also checked the water quality in terms of microbial water quality at the household level. So here you have the geometrical mean of E. coli contamination. And in the 5 intervention scheme, you see from baseline to endline a consistent decrease in contamination. And in the control schemes where we didn't apply our intervention, there was no consistent trend. It was in nearby community, but far enough. Same word? Separate word, yeah. So in the intervention community, we see a mean reduction of 17 E. coli. And then we sampled water quality in each scheme at the household level, the reservoir level, and the tap level. And in the intervention schemes, we saw a decrease in each of these sampling points, but 2 of them were statistically significantly proved. So at the household level and at the tap level, there is a significant decrease in contamination. At the RVT level, you see also a decrease, but due to the low sampling size, we couldn't find a statistical significance. So to sum up the key findings, the baseline scenario before our intervention was already pretty optimistic. The people were in general happy with their water, and we didn't see huge contaminations in the system, so it was already working pretty properly. But we still saw a big uptake of household water treatment in the intervention zones only, going from 70% to 100%. And also the water quality significantly improved in the intervention zones at the tap level, where we went from an intermediate risk to a low risk, even going having half of the tap at the WHO guidelines. And at the household level, we went from a high to intermediate risk to a low intermediate risk, with again half of the households at the WHO guidelines. So after this 1 year of REACH Catalyst project, we shifted to an 18 months extension of REACH Accelerated project. So this is happening right now. And we're going to replicate what we did in Dulu in 4 new districts. So we're going to expand this project. And what do we expect from this project? We want to extend the safe water services to 4 new districts, so 5 in total. And we want to generate recommendation for replication in other districts and other countries. So for that, we're going to upgrade 18 additional pipe schemes, again with source protection, chlorination, repairs on the scheme. We're going to install new rural laboratories and knowledge centers. We're going to establish the regular monitoring and inspection in each scheme. And we're going to share our knowledge via policy brief, conferences, and all of that will be open source. So a lot of reports are on their way to be published. So please keep in touch with us if you're interested. So I'm going to give back the microphone and we will take questions later. Thank you.
Okay, thank you very much, both Ariane and Madonna. Actually, we will have one more presentation before we go to the questions. So I'd like to invite Dorian Robinson to just give a little bit more of the details about the practicalities of this work. So Dorian, I'll hand the microphone over to you.
Hello everybody, so I'm going to follow up on the presentation that we just had and going a bit more into some details of the approach that we implemented in the field. I'm skipping this. So Ariane presented the scope of all the project and the activities that we did there. And I'm going to focus more on the part about the training and the lab installation and material that we used in the field. And also about the scheme improvements and the activities that we did in the water schemes to improve the water safety. And the monthly monitoring that comes as a support for interventions. So in the 5 intervention schemes where we saw that there was an improved water quality after intervention, we applied a risk-based strategy with these field laboratories, and important aspects was the capacity building of the local people that were involved in all the phases of the project at the laboratory level, but also at the community level and the scheme inspection. So we call it Adapted Water Safety Plan, or as Madam said, Water Safety Plan plus plus plus, with this improvement and this additional monitoring that we did. Sorry. So the risk-based approach for safe drinking water, with this Adapted Water Safety Plan and the local capacity building, what was done in the field is that there was creation of the Water Safety Plan task force that was responsible of planning and helping to implement the Water Safety Plan that was planned. So one of the big activities that we did at the beginning was a sanitary inspection of the whole scheme with this Water Safety Plan task force, to understand where were the weaknesses of the water scheme and how the water could get contaminated, and to capacitate the local people to understand how it works and how the contamination can go into their drinking water system. So here in the picture we see actually the people checking some of the structures of the water supply scheme for this sanitary inspection. So mainly capacity building and establishing afterwards measures for improvement of the safety of the water. So as mentioned before, sources are one of the main points where we worked because they are very vulnerable. here we see a picture where the source is mostly not protected. So contamination could come from rainwater, for example, into the drinking water supply directly. So with the interventions that we did in the field, so there was source protection with also surface runoff diversion to protect from runoff contamination, and also intake improvement. So we see on the picture here installation of a sand and roughing filter as a second measure after the source protection, and also 3R measures, so recharge, retention, reuse at the source, which are measures that will give impacts in few years because trees and everything have to grow until then, and this helps the source protection measures. Then other activities that were done was training the local community to perform improved maintenance on the scheme and better cleaning practices of the scheme overall, because we noticed that in some parts the maintenance was not so good. And also the last point was chlorination that we implemented in 2 of the schemes. We see a picture down here where chlorination is done. So for now, chlorination is done only by pouring chlorine into the reservoir tank, and we are looking into ways to do passive chlorination for the further steps of the project. Alongside with these improvements, there was also this hygiene and behavior change campaign and household water treatment and storage promotion with the use of these ceramic candle filters that you saw in the results that made the household water treatment levels reach 100% at the intervention schemes. So altogether, all these interventions are making a multi-barrier for the protection of the water, because if we have only, for example, one of the barriers and this barrier fails, then the other ones would be there to protect the water in a better way. And this is just a picture of the participatory approach that we implemented with community people learning how to do the chlorination in their water scheme. So now one of the questions that we are going to look together is how to monitor this drinking water quality in the rural areas. So we talked about, the regional labs that are very good labs that can perform all the analyses that are needed if they work properly, but it's very difficult to have many of them and that it covers the whole Nepal area, because travel times should be very short for water quality analysis of microbial parameters. So then there is this field kit that can be WACTEC or Delagua, or maybe there are others, that are very useful because they are fully equipped and we can go to the field and check the water quality with this. But they are very expensive, they require a very trained person to use, and actually if you want to cover the full area of Nepal, for example, it would demand a lot of travel between places, which might not be so sustainable in the end. So our approach is a decentralized lab unit that is a very simple incubator that works on solar power. So it stays close to the locations that we want to monitor. It can incubate at 37 degrees for 24 hours, what is needed for microbial testing. It's solar powered, and so this is like an intermediate solution for the water quality monitoring in the rural context that is working quite well. So the field laboratories are equipped to measure E. coli and total coliform with filtration kit from Delagua, compact dry plates that are materials, plates that are ready to use and sterile, so it's equipment that can go to the field and stay there and can be used easily even in the difficult conditions of the field work. As well as these membrane filters and wall bags to take samples. Everything is sterile and ready to be used in the field. So I have some of the material here. I'm not going to show it now, but if you're interested in seeing all of this material, we can have, you can come to the table at the end and check all of these. So on the right, we see the incubator and the solar setup that we installed in one of the labs. So these incubators are field-robust, solar-powered incubators for microbial water quality. And this is one example of a compact dry plate that gives us the results for microbial water quality, E. coli and total coliforms. So the incubator that we see here is the first version of the incubator, is the one that we used in the field until now. And this second incubator is the new version, upgraded one, that is, what is upgraded about it is that it can be constructed with very common electrical material and shell that can be found anywhere. Here we use the cooler box, for example. And with this kind of material, then it's also easy to repair and to use it in the field conditions, because this incubator can be built by somebody with the material that we developed and be ready to use anywhere. And it's also interesting because the size can change. So if you need a big incubator, you can build a big incubator. And if you need a very small one, you can build a very small one. Additional parameters that we are starting to test for the following phase is the turbidity and the pH and free residual chlorine. So with for the pH, we have these Delagua tubes that is a very simple tube that you use for testing the turbidity. And so this is a pool tester kit which is very useful for testing this pH and free chlorine, because it goes it's very small and it goes together. So you always need these two parameters when you check water quality for a chlorinated scheme. So the location of the laboratories was an important decision in the project, because so we had to find a place where the walking distance was close to these water schemes, and that one important thing is that one lab can cover several water schemes. So we can see here laboratory unit, and it can cover. We have worked with only 4 schemes for one lab, but actually it could cover many more if they are around the laboratory, which is interesting. Another point is the availability of staff that can be trained. So for that, we selected 2 places where there was educated persons that could be trained. So a health post and a school were the locations of the laboratories that we installed in this phase. So the laboratories, they are operated by trained local staff, and they can cover several schemes. A few pictures of, okay, I made a mess, sorry. So some of the pictures of the training that we implemented in the field. So we can see on the left, it's a training of a member of the community of the Water Safety Plan Task Force that is being trained to take water samples from his water scheme, and in the end he will bring them to the laboratory to be tested. And on the right, we see also a member of the community that is in charge of sanitary inspection of the scheme. So these both persons, they use a tablet for this work, and the tablet helps us then to upload the data directly on the cloud and be able to have different persons that are interested in this data to use it. And in the bottom here we see people that are being trained for the laboratory work, and in the middle part of one of the protocols and documents that we created for all these trainings. So all these trainings are available in English and in Nepali, if needed. So the next point is the costs of the laboratories, which is an interesting question. So I don't go into detail of everything, so I just will present the total. So the upfront costs for the laboratory setup, it's around $700 for one lab, equipped with the microbial testing, turbidity, pH, FRC tests. And then you have consumable costs. For example, for the water quality, the microbial water quality is $2 per test. And for the FRC and pH is 50 cents per test. A bit more detail about the regular monitoring activities. So these regular monitoring activities are about water quality and sanitary state, so sanitary inspection of the scheme. So for both, on one side we see here the laboratory staff that are performing this work. So they were trained in a group training at the beginning, and then in the field they were having follow-up trainings until they were able to manage the lab on themselves. And on the right we see again a community person that is taking water sample from his scheme. So both of these teams, they always communicate because they have to work together to bring the samples, to do the testing, and to bring back to the community the results of the tests. And additionally, there is this centralized data management, as we said. So all the data of water quality and sanitary inspection risk scores that go on the cloud. And here on the right is the places where we monitor the water quality and the sanitary state. So at the source, a reservoir, tap, and household. Battery. Thank you, madam. Okay, so here is a risk table. So when you have to decide about an intervention, you can check about the water quality and the sanitary inspection score. So both of them indicates you if there is a need of intervention at that point. So this is to resume what we do with this water quality and sanitary inspection tests. So monthly, there is this scheme inspections and water quality testing in each of the schemes. With this data, then it's analyzed or by us or at the community level where it's discussed, and improvements are done if necessary, and actions are taken to improve this water quality. And we see on the bottom backstopping from any person responsible of the scheme or an NGO that works there that can then close the loop, and this helps to inform all the decision-making process and target what are the urgent actions that have to be taken to protect the water safety. So just a few conclusions. So we saw before that there are promising results achieved with this risk-based approach, including the laboratories and the monthly monitoring that helps support all the decision-making processes to improve the water safety. There is an increased involvement and awareness raising of the community because they have been involved in all the steps of the project, from planning with the water safety plan and all the monthly activities that are done for monitoring. And the monitoring that is performed there complies with the demand of the monitoring guidelines of the national monitoring guidelines. So not the water quality guidelines, but how many times we have to monitor the drinking water in rural areas. So the next steps is scaling up, as Arjan said, and improve the strategy based on the lessons learned. And few of the challenges that we are facing is material supply chain, training and capacity building at a larger scale, and cost and who pays for everything. That's it.
Thank you very much, Dorian. Okay, well, I'm a little bit lonely sitting up here, so I'd like to invite you, Dorian, Ariane, Madan, and Mr. Kanel to come up. We've got 15 minutes for questions, so if you'd like to put up your hand, I don't know if we can, maybe I'll just pass the microphone to you. I suggest you say your name, who you'd like to question, and then give your question. And maybe we'll take 2-3 questions and then hand over to the panel. Okay?
Hello, namaste. I'm Pramina Nagarmi from Environment and Public Health Organization. Well, thank you to all the presenters for clear and very precise presentations, of course. My first question is for Narayan sir. So you mentioned that arsenic is a problem in Kathmandu. Because I'm from N4 and I look after the laboratory unit, we haven't found arsenic contamination so far at hazardous levels in Kathmandu. So I'd like to know if the data is based on some research or testing done. Yeah. And also, I'd like to add one more to that. Since we're talking about central database system, I was just wondering if you're planning to get the data that we have from years also updated in the database system, because that would really be helpful. Yeah.
Okay, thanks. Let's take one more question, then we'll go to the panel.
Thank you. Good evening, everyone. I'm Manish Baiti from Kathmandu University. My query is for Narayan sir. You mentioned that water quality database will be available in DWSS web portal. I was expecting from when we can have an access to that data. And my another question is for Mr. Madan. We have seen that there has been 35 days of continuous temporal and spatial monitoring of variation in E. coli. I've seen there that there have been monitoring from intake, reservoir, distribution point, and tap, but I was surprised not to see a point of use quality monitoring in this temporal and spatial variation, and want to know why was that missed. And again, another question to Ariane. While seeing to baseline versus end-line changes in the indicators, we have seen a very good change in the treatment practice, like 100% of the households were practicing drinking water treatment. When we came afterwards, that we came to know that chlorination was the main practice. Weren't there any complaints from the households regarding the taste, or how was the treatment practice acceptable? Because many in other studies where we try to intervene chlorination as a practice, as an intervention, it was a big problem for many of us. And again, I
know she had too many questions. I'm going to take the microphone off you. How many questions was that? I think it was at least 3 or maybe 4. 3, okay. Does anybody else want to raise a question, or shall we go straight to the panel? Okay, let's go to I think Mr. Kanali was first for you.
Okay, thank you very much for pertinent questions. I have 2 questions from the different audience. First of all, regarding the arsenic concentration in the groundwater in Kathmandu Valley, I want to highlight that in the deep boring, it is above the 200 meters and more. In the middle and the southern range of the Kathmandu, Bhaktapur and Lalitpur, we have found some arsenic concentration from 50 to 100 ppb in the deep boring. It is, if you want to look at the Tikatali, is a major dominant with the arsenic concentration, and we have now installing some treatment units with addressing the arsenic concentration downsizing to out below the 50 ppb. That is the situation right now, and government is initiating to investigate the further on the arsenic concentration in the groundwater in Kathmandu Valley. Right? Regarding the second question, regarding the database on water quality, department has initiated to maintain the database on water quality after the NIP database is already set up. And we have already captured the non-digital data, past non-digital data and digital data, and the software is already developed, and it is the time for just testing period. I already mentioned that very soon we'll public some general data to the public access. Right now we have the 5 laboratories, and we have the access to into the data from the 5 laboratories directly. And we are thinking how much data and which type of data should be public general, and which type of data should be put inside, so with some permission of the laboratory. So very soon we will public this data. Please wait. Yeah, please. I think I addressed your question also. Thank you.
First of all, thank to Manishi for your good observation. Regarding this data collection at the point of view in this research conducted for this temporal and spatial variation of water quality, actually we collected the data for household as well. But because of this hygiene behavior, it's really difficult to plot in the graph. For the household, it's like 1,000 equally, or very low because they are also adopting this household water treatment system. So we have data, but we haven't included those data in that graph. But in that graph, actually, we can just observe that if there is higher concentration of E. coli at the intake, so it is also higher at the reservoir or tap stand. So that graph has a clear relation with the intake and other point. But for the household level, it's really difficult to make this analysis with the concentration at intake and household level. That's why we did not include those data in that graph. Thank you.
And if I may just add on this question on the graph, the idea was to understand the dynamic at the scheme level, to see where the contamination came from. If it was from source contamination, or cracks in the system, or problems between the reservoir and the distribution chamber. And what we saw is that it was very consistent through the whole scheme, so it mainly came from the source. So I had a question about the acceptance of chlorine. So the way we wanted to introduce chlorine was to increase bit by bit the dose of chlorine, because based on other projects and literature research, it has been proven that when we increase gradually the dose of chlorine, it's very well accepted. If you overload the system with chlorine from one day to another, people complain. But I was not there in the field to really receive the complaints or the acceptance, so maybe I can ask Dorian or Madame to answer this question more in detail.
So for the implementation of the chlorination, it was first it was good because the community agreed on doing this practice, so they were fully aware of what we were going to do there, and that already started helping to be able to start these activities. And as Arjen said, if we start chlorination with a low level and go up slowly, this helps to adapt to the taste of the chlorine, because the human body just can get used to it. And if you never tasted chlorine before and you put the normal dose, then you get really sense of its tasting strong. So I think we had some feedback from the field that actually Ducia started tasting like chlorine, because it might happen that there were some problems on the practice on chlorination. So we really have to be careful and monitor how it's done, and maybe give additional trainings afterwards, because most of the time when there is problem about taste and odor of chlorine is because it's not done in a perfect way, and maybe it's overdosed. So this is why it's important to add the test that we showed about free residual chlorine to be sure that it's in the range. Yeah.
And also we are going to investigate passive chlorination system that actually automatically dose the chlorine directly in the reservoir, which would avoid this overdosing problems.
I think that's all the questions from the first round answered. Would anybody else like to ask a question? Yes, sir.
Thank you. I'm Mingma Sherpa. I'm from Fiber B Solutions, a private consulting company. My question is to the on the mobile labs. It's interesting. I mean, all the project concept, everything is interesting. So actually, my question is, how do you sustain a system that you have a continuous monitoring system in place? And the charges there, I'm not sure. I've seen a lot of labs. 16 years back, I worked with Matthias. We used the Deliver kit to do a lot of storage tests there. And some of these Deliver kits just left idle, it was not used. So often in these small communities, it's you give the kit, you train, and then this person leaves, and then there's no testing after that. So maybe we can think on the line, how do we sustain continuous monitoring campaign? How do we create that demand?
So first, in the end line, we asked the local communities about if they would be interested in having their water tested. And we saw that the awareness about the water quality raised because the people were even saying that they would be interested in paying for getting these tests. So the communities there are very poor, so it's a hard thing to imagine. But for the sustainability of the lab, so first with the staff that we selected is staff that is probably going to stay a long time in the schemes and in the villages because they are working there since a long time and they live there. So they are not going, hopefully, to leave soon. But it's true that this sustainability aspect is very important. And for the cost, so now we are, I don't know if Madan wants to say something on that better.
Actually, this is very much good question. When we started this intervention, when we designed this project, actually, we from Helbitas were very much reluctant about how it will be sustainable. It's fine now, this project or Eawag or Helbitas can support local community or users committee with this equipment and other things. But what will happen after the project? So it will again, since Helbitas has been working in water sector since long time and we believe on sustainable interventions. So then people come to Helbitas. We cannot go for this project. Actually, initially we were reluctant. But looking at again, we have opportunities also, like sustainable development goal. So we need to go for the safe water again. Government of Nepal also formulated this water sector development plan. There also target for higher service level. So we haven't to wait. We need to find some promising approaches or technologies that can work. And still, we are discussing with the municipalities that how we can sustain this regular monitoring. And because of this decentralized role to the municipality, we hope municipalities will also be interested to invest for the water quality things. And here actually we have placed this lab in the health post. Because at that time also we discussed if we keep this lab in the district headquarters, then who will own this? Because of this fertilization in Nepal. Later we decided let us go for the health post or school so that municipality later can take over that lab. The idea was that. And even now we also see again the challenge of this supply chain. What about the compact dry plate? How can we supply that? Even if municipalities are interested, then it's difficult to get in the market. That is the question still now. But anyway, we have to go for the this to achieve the sustainable development goal, and maybe for certain time there is a need of support from the project or external agency, and gradually we would like to give this role to the municipalities.
Mr. Khatri, I know you want to ask a question. I just have to warn you that actually it will be your session next, which might be cut if we have too long a question. I'm afraid we have to go on because it is Mr. Khatri's section next. Okay, thank you very much. We will continue. Feel free to sit there or go back to your own seats. Okay, then please, Mr. Khatri. So Namraj Khatri, who is a specialist in water safety planning, I'll hand the floor over to you.
How long I should go?
You've got 15 minutes.
Oh, 10 minutes. No, I'll do this because I didn't have any. Yeah, I didn't have any presentation, so I'll just speak. And my speech is triggered by what has been presented by these 4 people and plus. So first I will explain a little bit on water safety plan. Then I will link with the water safety plan plus adapted by them, and then I will link finally to the SDG. So then I will conclude. So water safety plan, main purpose of water safety plan is to have the safe water. Every drop of water coming from the system should be safe, drinkable. This is not one-time job. And there are certain steps. And this day I do not memorize water safety plan step because every agency has a different step and I'm not working with any agency. So I need to start from the basics all the time. So I will start from the basic. So in any system, there are certain point of contamination. So what contamination is likely either in the source or in the reservoir, or if they have the treatment plant, or in the network, or even at the household level. So the point has to be identified, what we call hazards. And all these hazards has to be controlled, means we should stop the chances of contamination. And these 2 are the main steps. And once we have, if the hazard has not been controlled now, we need to improve and make control. So that is the improvement. So once the system is in place, control is in place, and this is not one-time job, this should be monitored regularly, whether this control is working or not, and water from the tap is safe or not. That is monitoring, and that monitoring can be verified from the different level depending upon the national policy context. And these are the main water safety plan. But to implement this, we need to understand the water supply system itself, what we call the system description and the making the map. And with all this, there has to be somebody to implement this, and for that we imagine the water safety plan team. Sometimes what users committee itself is water safety plan team, and sometimes we create the different one. And I'm thinking about this rural context. And for this water safety plan, we need some kind of support mechanism. We need laboratory, we need the regular supply of the fund and materials for the improvement. Improvement is also not one time. So in that context, we have imagined this community-wide water safety plan. Generally, water safety plan is applied at the system level. The manager, this operator or users committee, they are the responsible. In the context of rural, maybe there are certain support mechanisms that can be shared. So we imagine previously it was VDC, now we have the Gaon Palika. Within the Gaon Palika, they can have the single water safety plan so that they can implement many of the things in common. For example, this laboratory. Everyone cannot have the laboratory and it is not available in the remote area. So they can share this laboratory that costs like 700. Within the Gaon Palika. One of the users committee can have that bigger one, or even it can be installed in the school, or even this Gaon Palika itself. There must be some kind of the wash unit, and they can maintain this. So they have already adapted. It was only in thinking. It is in the guidelines somewhere in the Dolidar, but you have already implemented. That is the solution. And this water safety plan. Plus things. They have added this water quality monitoring and this source conservation and some others add the plus. Actually, this is a part of the water safety plan. That is what we call support mechanism. It is also in the guideline, but it looks like generally we neglect these things. So you have added this as a plus. Similarly, this Finnish project in the far western region, the RBWRMP, they have linked this water safety plan concept with source conservation. Generally, they prepare the water use map. Actually, that also came from this Alberta's experience. And they have linked with this source conservation or watershed management or climate change, all this. And that is also, the guideline is also plus, water safety plus. and finished project in this Pokhara, and they have linked this water safety plan with operation and maintenance. People understand operation and maintenance, not water safety plan. That is the regular tasks in the water supply system management. So they have combined this operation manual and the water safety plan for them, that is plus. And recently WHO has added the climate change thing with the water safety plan. Actually, climate change also ultimately come out with some kind of that risk of contamination, and that is the additional, they think that this is the additional risk, so behind our general thinking, so they have added this and what they call climate resilient water safety plan, and that ultimately focus on this source conservation you have already practiced. And this source conservation is the one of the most important activity, whether you simply think the water supply management or water safety plan or climate resilient water safety plan. All these ultimately demand the source conservation. Source conservation does not mean the conservation or protection of intake point, it is the whole catchment area. And that will directly address to the 5 of the SDG goal. In SDG, there are actually 8 goals, and last 2 is related to support and the capacity building. Actually, target there are 6, and out of 6, 1 is related to sanitation, and the other 5 safe water, and this water quality, and effective use of water supply, and ecosystem management, and the integrated water resource management. All these 5 goals will be addressed by this source conservation, and including this water safety plan. And so in that context, what you have done is very much in the right direction. Only thing is, it has to be replicated. Generally what I see is, all these NGO, they are working in certain part of the Nepal, and they use their research, or what I call this operational research, because you are piloting and getting doing the research and coming out with some kind of the positive result and practicing again. And most of it is limited within the organization. So once I visited one of the training organizer, one of the agency, and ultimately they asked how our program looks like. And actually I would have to say it is a very good program, and said no, value of your program is 0. Because why I said 0, because once your funding will, in some stage your funding will stop, and the next day nobody will understand what you have done, because it has not been linked with the government program, or even in the local level. You are working this as independent. Now you have a lot of this budget and funding and the national, international export, but the next day when this program stops, there will be nothing. And same thing happened with all this Finnish supported program, but they are continue, but their experience of previous program is 0. And when they stop, but now many of the agencies, they have started working with the government. And when we look from the government side, we have all kind of experiment in this Nepal. Best sanitation program, best community, public toilets, and best this source conservation, best water safety plan. Everything we have for the model, but it has not been replicated. So what I saw is, actually I had already heard about this program in the Philippines. One of the, I don't know who was that, and I knew from the Philippines that this program, this source monitoring system. So we have everything, but only thing is we have to somehow, in some stage, transform this into the government guideline. So once it is transformed into guideline, and even you left the program, or even you stop the program, and that will be carried out. And for example, this water safety plan, it was promoted by WHO. Actually, WHO is responsible for providing guidance, but with some OZ funding, it was first piloted and replicated, and ultimately government accepted this as a national program. Now that his main job is water safety. He has incorporated. Similarly, So this Helvetas program, actually you are working jointly, all three. So in some stage, if with these positive results, so actually water safety plan is a risk management. It will not give complete solution in one time. Risk management means more this E. coli contamination we reduce, so less the people are exposed to minimum risks. So you have clearly explained from your presentation that this E. coli is going down with intervention. Without intervention, it will not happen. It has been clearly shown in your presentation. So that is the main thing. Even we need the zero E. coli in the tap, it may not be possible in all the system or in all the times. So if E. coli is reducing from 100 to 50 or 20, from the 10 to 1, so people should be happy. For example, when this water safety plan was applied, before that people were accepting the 50 E. coli in one of the system. They were drinking without boiling. So when they applied the water safety plan, they reduced up to 5. And same time this disaster happened in the western Nepal, in far western, and they were in the western, and they started boiling even with 5. They were more conscious, and later they improved the catchment area and reduced to 0 or 1, something like that. So thank you.
Okay, Mr. Khatri, thank you very much indeed. You mentioned about research not being streamlined into the system. We do also have Dr. Subodh Sharma here, who could perhaps just give a few words on research, academia. 5 minutes, Dr. Sharma.
My God, we still want to mention.
Well, there's 10 minutes left and you've got 5 of them.
Yeah, well, 5 minutes is more than enough. I've been told it's an honor for me. Like, by the end of the day, we all are exhausted. A few take-home messages. Myself, I come from academia, Kathmandu University. Academic institutions in this country, like, you can categorize their curricula into 3 different categories. One, gray sector. Gray sector institutions are like engineering institutions or agricultural institutions. Their focus, agricultural institutions, their focus is mostly on looking at how agricultural intensification is going to affect water quality. But friends, like this, quality and safety has been keyword today, this evening. Both are related terms. What I consider as good quality or what I consider as safe. Clarity is not necessarily an indication of cleanliness. Sometimes the more clear the water is, more contaminants it might be. Agricultural institutions, they are involved more in such issues. Engineering institutions, they are involved more in designing mechanical devices, candles, filters. They are the ones who are involved in it. Kathmandu University is also very much involved in these things. And then now we have forestry institutions. Their focus is not in gray sector. Their focus is on the green sector. And they are mostly involved in research of the type where they say that misconception, trees yield water. No. If a certain patch of land is well forested, our misconception was that there must be enough water. That is not the case. What matters is what species of tree is there. If it is an indigenous species, yes, yield will be more. But if it is an exotic species, evaporation loss is high. Water will be less. I come from environmental institution, Department of Environmental Studies. And my focus is blue sector. I work in water. It's because my sector is blue and water quality, I not only trust on water chemistry, but trust more on water biology. Our focus is considering E. coli. And now I could hear some of you are also interested in arsenic. That is also a compromise. Out of 108 elements which are there in periodic table, we are considering only 2 elements and trying to assure that the water is safe. No, we are misguiding. Unless and until certain parameter is thoroughly analyzed, we cannot say that water is safe. We have come to a conclusion that this water is free from E. coli, it is free from bacteria. That's the conclusion we can derive, but we cannot say that it is safe. unless arsenic problem was derived from UNICEF Bangladesh, it was not the case. Lead has not been addressed in this country. That is going to be a big havoc in future. Fluoride in the Tibetan plateau flourishes. You must have seen people with thick teeth. That is going to be a big problem in the days to come. As an institution, our problem is the data sharing mechanism is extremely poor. Our focus is more and more on achieving degrees. We are collaborating less with line agencies. So in the days to come, my sincere appeal, Helvetas has been an eye-opening for me. I have been working with Helvetas for pretty long. I have been to some of their sites. Now, Helvetas and academic institutions, let us try to pack the knowledge which we have already generated. Let us pack that knowledge, and in a packageable form, let us bring that to the community. That must be our future mission. Let us not keep on testing candles which are produced by someone with commercial mission. Let us use local resources, limestone from our Ture range, or other materials locally available, and develop candles, and then let us test our own candle, prepare our own filters, and then bring that to the communities. That's where I see future. Have a good evening, and I end with that. Thank you so much for giving me this opportunity.
Thank you very much, Dr. Sharma. Okay, so it falls on me just to round up. I think we can already hear people outside who are enjoying the drinks or whatever food there is for this evening. We're sitting here in very opulent surroundings. We should really think about going back to the community, about working with the people who really don't have ready supply of safe drinking water, and really think of them as individuals. Think of them as being citizens in Palikas. We need to be working at the local level. I think that is also something which has come out from today, that all that we're doing, it has to be replicable, sustainable at the local level. And talking about institutionalizing all that we're doing into the government service, that is now going to be also through the Palikas in future. So let us really think how this experience can be replicated through the different Palikas. But with that, I would like to thank all our speakers. So, Madan, I think you had a lot to do with organizing it. Madan Bhatta from Helvetas. Mr. Kanal, thank you so much for giving your keynote address. Ariane, Dorian, thank you also for all your inputs. And then, yeah, Mr. Khatri and Dr. Sharma, thank you also for your words. So, thank you everybody for being here at the end of a very long day, and I hope that you really have something to take back after this session. Okay, good evening.